possible to analyze the data and to get a clear cut information related with any particular incident. Okay, so it is important. Okay, statistics it is too important for us. Clear? If you are going for higher classes and higher studies also, statistics is too important. So base is necessary. From 9th class onwards, you are learning that things. Okay, these things that related with statistics in mathematics, right? Okay, now the use of statistics in what you can say economics. So too important for us. So all these ideas, all these formulas, okay, are important. You have to keep that in your mind and want to understand how to solve all these problems there. Okay, and come back uh, today. This is the last thing what we discussed in the classroom. That what quartiles, right? Quartiles and percentiles completed, and in quartile we discussed about the calculation of calculation of quartiles. Okay, so calculation of the quartiles in the sense this equation we used to q1 is equal to n plus 1 divided by 4 item, and the same example I showed you what is the method we are using to find out this answer. Okay, number of questions we discussed in the classroom. Again, you made mistakes in that. Again, write one more question. Okay, this I will explain this again. Okay, so this example, the same example from the textbook, just observe it clearly. Observe it clearly. Okay, calculation of the quartiles. Okay, so here you can see quartiles basically we are using to divide the full data into 4 equal parts. There are 1 2 3 4 equal parts, right? So lower quartile is the 25 percentage, lesser than that, and 75 percentage higher than that. That's what the lower quartile. And the median, okay, the middle quartile, the second quartile q2, that is 50 below and 50 above, 50 below, 50 above. Upper quartile, that is termed as q3, q2, q1, q2, q3. So upper quartile is 25% is above and 75 is below. Clear? That's what the basic idea of the quartile. Okay, and we are going to find out the Q1, quartile 1 for a set of data, quartile 3 for a set of data, how it is. Okay, so there are data is provided here 11, 12, 14, 18, 22, 26, 30, 32, 35, 41. Okay, so in the question it is not like that. We rearrange it like this. Okay, so question it is not in a correct order, and we arrange that data into an ascending order. Keep that in your mind, ascending order. Okay, the whole data we divided, sorry, we rewrite like this. What lowest number is 11 and the highest one it is 41. Okay, so arrange all the numbers in between. Okay, and we are applying that in the equation q1, the size of n plus 1 divided by 4 because the quartiles are dividing the entire data into 4. Okay, 4 sets. Okay, that's what 4 here. So q1 is equal to size of n plus 1 divided by 4th item, the size of so here it is n plus 1. Okay, what is the n here? 1 2 3 4 5 6 7 8 9 10. So that's a number n, total number of items. Okay, 10 plus 1 divided by 4. Okay, 10 plus 1, that means 11 divided by 4 is equal to 2.75. Okay, so 2.75 item, that's what the answer for us, right? 2.75 item, the what we can say the answer what we got after completing this equation, applying that numbers in this equation, we got 2.75. So if you are calculating that, we know that there is no such item is existing in this set of data. No such item is existing. 2.75, 2 is there. Okay, so 2, we go for 2 here. Second item 2, so 12 plus 7 point is 0.75 is there, right? So 0.75. Okay, that should be multiplied with the third item minus the second item. Okay, so the 7.5, the balance will go to the next item. So here it is, third item is a 14. So 14 minus second item, that is a 12. Okay, so we got like this 12 plus, okay, 0.75 multiplied by here 14 minus 12, it is a 2. Okay, so 12 plus 1.5, the answer is 13.5. You got the idea? This is the method to calculate that. Okay, so don't make any errors there next time. Okay, next one, going for the third quartile, the equation will simply change like this: 3 into n plus 1 divided by 4th item divided by 4. So what do we do here? Okay, the three want to add because this is third quartile, third quartile. So three. Okay, that's what the difference. Only difference. Okay, so just to go for a homework today. Now itself you have to complete that. Let me check that. Okay, so 10, 12, 14, 16, 18, 20. Okay, and 22. Clear? 22. Just to find out that. Come on. What's the answer? Asking about the Q1, quartile one. What's the answer?
Q1 is 2.
Yeah, Q1 is a 2. Okay. So 7 plus 1 divided by 4. 8 by 4 is equal to 2, right? So what are the digit here? What is the Q2? Sorry, Q1. That is 12. The
10.
second item. Okay. Second item. That is 12 here. All right. So 12 is the answer. Q1 is 12. Clear. Then go for Q3.
Q3 6.
Okay, 3. Okay, 2 into 3, 6. Sixth item. The sixth item here.
20.
Okay, Q3, Q1. Okay, clear. So simple method to find out data. So if it is even numbers, so sorry, odd numbers, so easily you can find it. Coming to even numbers means this kind of things will be there, right? Right or not? Okay, so that's the thing you have to keep it in your mind. Next one we are moving to. I will give some example today. I mean some homeworks. Moving towards the mode here. Mode. Okay, sometimes you may be interested in knowing the most typical value of the series or the value around which maximum concentration of items occurs. So we completed that, right? So mode, we know that mode will denote with a MO, MO. Then what about the median? Median, median is a ME. Sorry, mean is a ME. Median is MI. Okay. So ME means a mean, MI median, MO mode. Okay. Clear? Okay, so MO, it is denoted. So the mode is the most frequently observed data in a set of data here, and it will denote with MO mode. Okay, so discrete series we calculated here. You know that the data set 1, 2, 3, 4, 4, 5. Okay, so easily you know that two number again the same number 4 that repeated for 2 times. Okay, so most frequently twice in the data. So answer is a 4 there, right? Right. So what about this double one, double two, double three, double four? Can you find the mode of this set? Can you find? Impossible, right? All numbers are repeating twice, right? Repeating there. Okay, it's impossible. So here, look at the following discrete series. Okay, variable and frequency 10, 20, 30, 40, 50, 2, 80, 20, 10, and 5. Okay, so here, as you can see, the maximum frequency is 20. The maximum frequency is 20. So here we are going to find out the computation of mode discrete series. Here in frequency, the maximum frequency is 20. Here, as you can see, the maximum frequency is 20. The value of mode is 30. Okay, value of the mode is 30. So 20 related with that the variable is 30, right? So the mode is 30. In this case, as there is a unique value of mode, the data is unimodal. Okay, unique value is there. That time we can say that the data is a unimodal data. Unimodal data. Okay, so there is no repetitions are there, right? But the mode is not necessarily unique. Unlike arithmetic mean and median, you can have data with two modes. Okay, if two modes are there means we can say there's a pi model, or more than two modes are there means it can termed as a multi-modal. Clear? Okay, two are there means bimodal. More than that, more than two is called to be multimodal. It may be possible that there may be no mode if no value appears more frequent than any other value in the distribution. For example, in the series double one, double two, double three, double four, there is no mode. Okay, so is that clear? Right? Clear, right? Okay, just read it and understand that. So unimodal data. Okay, you can say only one mode will be there, right? Okay, so one number, the maximum. Okay, coming to the bimodal, two are there, right? Two are there, bimodal. For the multimodal, we are able to find that the many will be there, many are there. Okay, so what the important point here related with a single mode unimodal, we can see that a unique value will be there, the highest value here. All right. Coming to continuous series. So discrete series is okay for you. Coming to continuous series, okay, I will give some example for that also. For doing as a homework here. So continuous series. Okay. So the continuous series, we used the same, almost same equation to find out median also, right? So MO mod is equal to L plus D1 divided by D1 plus D2 multiplied by H. This was the equation here to find out a mode. MO is equal to L plus D1 divided by D1 plus D2 multiplied by H. Okay, in case of continuous frequency distribution, modal class is the class with the largest frequency. Clear? In the case of continuous frequency distribution, modal class is the class with the largest frequency. Mode can be calculated by using the formula MO is equal to L plus D1 divided by D1 plus D2 into H, where L is the lower limit of the modal class, D1, the difference between the frequency of the modal class and the frequency of the class preceding the modal class, ignoring the signs there. Okay, so here's a small error is there. Okay, wait, we'll discuss that. So D2, difference between the frequency of the model class and the frequency of the class succeeding the model class, ignoring signs. So signs are not necessary. If it is negative or positive, we will exclude that. Okay, we will not use that sign here. H is the class interval of the distribution. You may note that a case of continuous series, class interval should be equal and series should be exclusive of the calculate the mode. Equal, and the series should be exclusive to calculate the mode. If midpoints are given, class intervals are to be obtained. Okay, so if only midpoints are there, means we want to find out the class interval. Okay, then only we are able to complete the task. Okay, example 11 here. Calculate the value of the model worker family monthly income from the following data. So income per month, that's in rupees. Cumulative frequency also provided. So it is our responsibility to find out the class interval. Okay, so going to find out the class interval. As you can see, this is a case of cumulative frequency distribution. In order to calculate mode, you will have to convert into an exclusive series. Okay, exclusive series, not an inclusive, but an exclusive series. In this example, the series is in the descending order, not ascending, but a descending order. This table should be converted into an orderly frequency table 5.7 to determine the model class. Okay, so we are going to complete that. First of all, you can see that less than 50 rupees, that is 97. Less than 45, 95 are there. Less than 40, 90 are there. Less than 35, 80 are there. Less than 30, 60 people are receiving salary like that. Less than 25 rupees, there are 30 people are there. Less than 20 rupees of salary, less than that is in thousands. Okay, not just 20 rupees, 20,000 rupees. Less than 12, less than 15,000, it is 4 people are there. 4 people are there. So you have to come. Construct a table here with the exclusive class intervals. Okay, clear or not? That also in a descending order. So we know that between 10 to 15, how many are here? Between 10 to 15, how many are receiving salary? Between 15,000. Sorry, less than 15,000. Okay, 15,000. Okay, there are. We took a class interval here, 10 to 15. 4 people are there. Okay, next one, 15 to 20, more than 15 and less than 20. How many are there? So that is 12 minus 4, 8. 12 minus 4, 8. We got it. Next one, next class interval, 20, 25. So 30 minus 12, 18. Clear? You got that, right? You know how to calculate this, right? Okay, already we did this when we discussed that OJ, right? Okay, next one, 2025. sorry, 25, 30, 30 people are there. So 60 minus 30. Here it is a 60 minus all these things. That's what 30 here, minus 30. Okay. So 30 divided by, sorry, 30, 35 group, 80 minus 60, that is 20. That is a 20. Next one, 35, 40, 90 minus 80, it is 10. And 40, 45 interval, 95 minus 90, it is 5 here. And 45 minus 50, that is 97 minus 95, that is 2 people are there. Okay, 2 people are there. Got that? How to calculate? Okay, so the value of the mode lies in 25, 30, the class interval. 25, 30. Here you can see that the maximum value 30, right? So that is the model class here. Okay, 30. Clear? That's the model class. Okay, the value of the mode lies in the 25, 30 class interval. By inspection also, it can be seen that the model class, now L is equal to 25. Okay, lower limit of the model class is 25, right? Lower limit of the model class, it is 25. D1. Okay, so what is the D1 here? Difference between the frequency of the model class and the frequency of the class preceding the model class mentioned here. Okay, but here they used the data here succeeding one, right? Succeeding that only 30. Here it is 18 below that, right? Clear or not? So preceding means they have to take 20, right? Yes or no? The preceding data 20 only, no? So here we want to make a change here, D1, D2. Cut here and write a D2 and cut here and write a D1. Okay, D1. Clear? Understand? Okay. So here L is 25, D is equal to, D1 is equal to, what is D1 here? Difference between the frequency of the model class and the frequency of the class succeeding the model class, succeeding the model class. So that time we can say that it is a 30 minus 18. 30 minus 18. What is the answer here? What is the answer here? 12, right? 12, right? So we go to the value of D1, it is a 12. Next one, D2. What is D2 here? D2, the difference between the frequency of the model class and the frequency of the class preceding the model class, which means again 30 minus 20. 30 minus 20, preceding the model class, 30, just above that 20. So answer is 10. Answer is 10 here. Answer is 10 here. All right. Okay. Next one, D1, sorry, we got L, we got the value of D1, we got the value of D2, and the next one we want to get the value of H here, H. That's the next one, H. Okay, H is the difference of the class, right? Right? Yes, what is the magnitude here? 5 only, right? 30 minus 25 is equal to 5. 30 minus 25, answer is 5 here, 5 here. Right, so we got all these values here. Well, we got D1, got D2, got H also here. And we want to apply this is in the equation. This is in the equation. What is the equation here? What is the equation? See here. MO is equal to L plus D1 minus, sorry, divided by D1 plus D2 multiplied by H. Okay, see the same equation here, right? Okay, can you see that? L plus D1 divided by D1 plus D2 into H. So we applied that. Okay, so MO is equal to, what is L here? 25 plus D1, that is 12 for us, divided by, okay, D1 minus D2, D1 minus D2. So 12 minus 10 multiplied by 5. Okay, so what is the answer? What is the answer we got here? See, 25.
It's 12 plus 10.
What is Shirya?
So it's 12 divided by 12 plus 10. You wrote 12 minus 10.
Yeah, 12 plus 10. Wait 1 minute. Yeah, 12 plus 10. D1 plus D2. D1 plus D2. So we go to 25 plus 12 divided by 12 plus 10 into 5. The answer is 27.273. Clear? Good. If you're calculating also the same answer will come. There is no trouble in that. Okay, so now just to rewrite this question and complete the example. I mean, one more example you have to do as a class work here. Just check it. Okay, rewrite the question. Okay. So the same question only. I'm making some changes here. Okay, so instead of this income group, income group, income group is here. So frequency F. Okay, I'm giving a direct data here. Afterwards, we will go for another example also. So go for 45 there, right? Okay, just copy that 45 50, 40 45, 35 40, 30 35, 20 25. Okay, so 1 2 3 4 5 6. 50 not correct. 40 50, 40 50, 40 45, 35 40, and 30 35, 25 30, 20 25, 15 20, next one 10 15. Okay, frequency I'm changing here. Frequency is equal to 8, 12, 15, 25, 18, 10, 7, 5. Okay, just complete this. Complete and send the answer. Okay, received some answers already. What happened, Shubham Bal? Little problem. What's the problem? Tell me. Shubham, D. What is D here? Here there is no D, only D1, D2, right? Yes or no? How to calculate the D1? How to calculate D1? Completed. Okay, so let me discuss that. What is the model class here? Model class? What is the model class here? Anyone?
30 to 35.
30, 35 only. 30, 35. The maximum frequency, right? 25 is the maximum frequency here. So 30, 35 is the model class. Model class. So L is what is the value of L?
30.
Model class. Lower limit of the model class is
30.
right. Okay, next one D1 is equal to D1 is equal to frequency of the model class, right?
7.
What is the frequency of the model class? Here it is 25 minus this preceding, preceding data, right? Given the preceding data or what we can say, succeeding data? Succeeding data, right? Okay. So 18, right? So what is the answer?
7.
7. 7. Okay. D2, the preceding value. So 25 minus here it is 15. So the answer is what is the answer? Shubham, check here. 10, right? Okay. Then what is the H here? H here? 35 minus 30. 5. Clear. Now apply this. Again, so it is L is 30 plus D1, that is 0.7 divided by D1 plus D2, that is 7 plus 10 multiplied by H. Okay. H is 5 here, right? 5. Clear. Okay. Now calculate. So we like here 30 plus 7 divided by 17 multiplied by 5. Then what is the answer? 30 plus 30 plus
7 by
7 by
the answer is 32.05.
2.05.
No, sir, the answer.
Yeah, then answer is 32.05, right? So if you're calculating this, you get 2.05. Is that correct or not? Check there. That correct? Okay, so go for another homework also. 2, 3 homeworks I will write now. Zero, 10, 10, 20, 20, 30. Okay, sorry. This is what we can say that exclusive series, right? Okay, so just to keep that in idea, exclusive series. Okay, so go for the same data only. Okay, so you're not going to create another data. 10, 15, 20. Okay, 20, 25. Next one, 25, 30, 30, 35. Okay, 35, 40, then 40, 45, 45, 50. Okay. This is the frequency, just for understanding. This is a frequency. So value of H always is 5 here. Okay. Then I'm giving frequencies here. I'm going for next one. 28, 18, 10, 09 and 05. Here it is 15, 12, 10. One homework. First frequency. Okay. So this is a set 1. Okay. Next frequency 2. You have to calculate this also. Frequency 2 here 8, 18, 21, 25, 40, 35, 30, 25. Another set F3. Okay, frequency 3 here 5, 10, 15, 25, 30, 35, 30, 25. Okay. So the same frequency, sorry, same class interval, 3 different set of frequencies are here. You want to calculate that, right? Okay. I'll submit by evening. So here it is 25. Okay, 25. I will read that. First frequency 5, 9, 10, 18, 28, 15, 12, 10. Second frequency 0, 8, 18, 21, 25, 40, 35, 30, 25. Third frequency 5, 10, 15, 25, 30 to 35. Next 30 and 25. That's what. Okay. Clear? Fine. Next one, we are going for the conclusion of this chapter. Okay. So we know that arithmetic mean ME, median, MI. That's a subscript here, mode subscript MO. Okay, MO. Okay, the related magnitude of the 3 are, okay, ME greater than MI greater than MO, or ME less than MI or less than MO. Suffix occurring alphabetical order. So EIO, that will come. That's alphabetical order. The median is always between the arithmetic mean and the mode. Okay, so conclusion. Measure of the central tendency or average are used to summarize the data. So answer for one question. Okay. So what is the importance of measures of central tendency? It specifies a single most representative value to describe the data set. Arithmetic mean is the most commonly used average. It is simple to calculate and is based on all observations, but it is unduly affected by the presence of the extreme meta items. Median is better summary for each data. Mode is generally used to describe the qualitative data. Median and mode can be easily computed graphically. In case of open-ended distribution, they can also be easily computed. Thus, it is important to select an appropriate average depending upon the purpose of analysis and the nature of distribution. Okay. So again, one more class we will take to recapitalize all these calculations and number of examples also want to complete in the class itself. Okay. So everyone, thank you very much. We'll meet in the next class. What happened to Shubham Pal? Shubham Pal is going for a crazy calculations here, Shubham. Okay, so simple to do that. Okay, so Shubham, we will discuss in the next class.